Systems of nonlinear equations in two variables. A system of nonlinear equations would be a system of equations with at least one equation that is not linear. So it could be the graph of a circle, a parabola, an ellipse, or anything that's not a line. So remember, when we're looking for a solution to a system of equations, if they're linear, then that's the point where the two lines cross. That would be the solution to the system. Of course, we could have no solution if the two lines are parallel, or infinitely many solutions if it's the same line. But in a system of nonlinear equations, say for example, if we have a line and a parabola, well, this would have two solutions because it's crossing at, the two graphs are crossing each other at two different points. If we had a circle and a parabola, we could have two solutions, or we could have one solution if it looked like this. Of course, we could have no solutions if they don't cross each other. We could even have two ellipses. An ellipse is like an oval, and if it looked like this, there would be four solutions. So in this, these are different than linear equations, but we can solve them using the same methods that we use to solve linear equations. The first method that we're going to talk about is using substitution. So if you'll remember, in order to use substitution to solve a system of equations, we need to isolate one of the variables to begin. So if I look at these two equations, the y in either equation would be the easiest thing to isolate, and it doesn't matter which one. I am going to go with the first equation and isolate y. So if I take this first equation, x squared equals y minus 1, if I want to isolate y, I'm going to add 1 to both sides of the equation. So this gives me x squared plus 1 equals y. So now I'm going to take what x is equal to, what y is equal to, and substitute that into the other equation for y. Okay, so now let me rewrite the equation and substitute in the x squared plus 1. Alright, so I have 4x minus, and now I'm replacing y with x squared plus 1 equals negative 1. Now, I replaced y with x squared plus 1, but y was negative. So I need to distribute that negative to both of these terms that I've replaced y with. Alright, so I'm going to distribute this negative, and that gives me 4x minus x squared minus 1 equals negative 1. Alright, and then I'm going to move everything over to one side of the equation. I'm going to add 1 to both sides. Well, the 1's cancel out, so I have 4x minus x squared equals 0. Okay, so in order to solve this, I'm going to factor. Well, I have a greatest common factor of x, so I'm going to factor out the x, and I'm left with 4 minus x. And now this is completely factored. I take each factor and set it equal to 0 and solve. Okay, so now I have x equals 0 and x equals 4. But remember, what we're looking for is we're looking for the points where these graphs cross. So these are just the x coordinates of the points. So for each x coordinate, I need to substitute it into one of the original equations to get the y coordinate that goes with it. So just like in the linear equations, it doesn't matter which equation we plug our coordinates into, just one of the original equations. But since I'm looking for y and I already have rearranged this equation for y, I'm going to plug it into that equation, my x values into that equation. Okay, so if I take 0 and I plug it in right here, then that gives me 0 squared plus 1 equals y. Well, 0 squared is 0, and 0 plus 1 is 1. So 1 equals y. So that's one of my, or that's the y coordinate that goes along with 0. So one of my solutions is 0, 1. Okay, and so now I'm going to do the same thing with the 4. Okay, so I got 4 for one of my x's. I'm going to take it and plug it in again to this equation. Okay, so if I do that, if I plug in 4 for x plus 1, 4 squared is 16, and 16 plus 1 is 17. Okay, so my other solution, I plugged in 4 for x, and I got out 17 for y. So 0, 1, and 4, 17 are the two solutions to my system, or that's the 2 points where these graphs cross. If you'll notice, that first graph would be the graph of a parabola because I have only my x's squared. And my second graph would be a line, and so this is just a parabola and a line, and so it's got 2 points, or 2 solutions, because it's crossing in 2 different points. Okay, here's another system of nonlinear equations that we're going to solve by using substitution. Anytime you have something that's squared, don't try to get it by itself. Don't try to get the variable that's being squared by itself, because then you have to take the square root. You have to take the square root of each part. It's plus or minus. Don't do that. It's best when you're doing substitution to try to get the linear equation to have something by itself. Or, well, in the one that we did before, it was okay because we didn't have to take a square root to get a variable by itself. So we actually got the quadratic equation by itself. But don't take the square root of something to isolate a variable. So let's look at the top equation, since that's my linear equation. To get a variable by itself in that equation, all we have to do is subtract 2y from both sides. So I have x plus 2y equals 0. To get the x by itself, all I'm going to do is subtract 2y from both sides. So that gives me x is equal to negative 2y. So now I'm going to take negative 2y, which is what is equal to x, and I am going to substitute that into the other equation for x. So I'm taking this, and I'm going to plug it in right here where the x is. Okay, so that gives me negative 2y minus 1 squared plus y minus 1 squared equals 5. So remember, whenever we have a binomial squared, we don't just distribute the square. That means that it's that binomial times itself. So we're going to have to multiply the binomial times itself by foiling. Okay, so I wrote each binomial twice. And now I'm going to FOIL both of the binomials. Alright, so I have FOILed both of the binomials. This would be these first 2 binomials multiplied together, and this is the second 2 binomials multiplied together. And now I need to combine like terms. Okay, so when I look at my y squareds, I have a 4y squared plus 1y squared, so that would give me 5y squared. Okay, so I'm done with the y squareds. Now let's look at the y's. 2y plus 2y is 4y. Minus y would just be 2y. Okay, so now I'm done with the y's. Okay, and I have 1 plus 1, that would be 2, equals 5. Okay, so I just need to move the 5 over to the same side of the equation as everything else. So I'm going to subtract 5. And that gives me 5y squared plus 2y minus 3 equals 0. Okay, so then I want to see if this will factor. Alright, the only factors of 5 are 5 and 1, so that would be 5y times y. And the only factors of 3 are 3 and 1. So let's do this. Remember, anytime we're factoring, we can check with a smiley face. This tells me that my signs are different. So I'm going to be subtracting. So this is a 3y and a 5y, which subtract to give me 2y. So it does factor. My 2 is positive, so I know that my bigger product needs to be positive. So this needs to be positive and this needs to be negative, which means that my plus sign would need to go here. Oh, well, my plus sign would need to go in my second binomial. My minus sign. Is that right? Nope, my plus sign. And my minus sign needs to go here. Okay, so that would give me a positive 5y and a negative 3y, which would give me a positive 2y. Okay, so once I have completely factored, take each factor and set it equal to 0 and solve. Well, I've written the page out twice and it deleted both times for some reason. So we're just going to finish that equation. Once we have it completely factored, we take each factor and set it equal to 0 and solve. So I have 5y minus 3 equals 0. Y plus 1 equals 0. Alright, so I'm going to add 3 to both sides. And I get 5y equals 3. Divide by 5. So one of my y coordinates is y is equal to 3/5. And the other one is y equals negative 1. Okay, so remember we need to get the x's that go with that. So we're going to have to plug it back into one of the original equations. And that second equation had the x minus 1 squared plus y minus 1 squared equals 5. That would be the most difficult one to plug it into. I'm going to plug it back into the linear equation. Okay, so that linear equation was this, x plus 2y equals 0. So if I plug 3/5 in for y into this equation, that would give me x plus 2 times 3/5 equals 0, which would be 6/5. And of course, if I subtract 6/5 from both sides, I get a negative 6/5. So this one solution, I would have negative 6/5 for my x and 3/5 for my y. Okay, now I'm going to do the same thing with the negative 1 and plug it into that same equation. Alright, so I have x plus 2 times negative 1 equals 0. So x minus 2 equals 0. Add 2 to both sides. And x equals 2. So this solution is 2, negative 1. Okay, so both of these are points where my graphs cross. And since that second equation had both terms squared, you might think that it's a circle, but, or no, that one is a circle. Yeah, because it's x minus 1 squared plus y minus 1 squared equals 5. So the x minus h squared plus y minus k squared equals r squared. It's a circle. So we have a circle and a line, and they're crossing in 2 points. Now let's try solving a system of nonlinear equations in 2 variables using addition. So when we're using the addition method, we have to make sure that both equations are in the same order, meaning that, you know, our like terms line up so that we can add the 2 equations together. All right, so that's already the case in this equation. They're lined up, so let's just see what we need to do to make one of the terms cancel. So remember, they have to be the same or additive inverses of each other. It has to be the same number with different signs. So nothing's going to automatically cancel out if I add these 2 equations together. I always try to get the smaller coefficients to be the same. So if I look at these 2, the 2 and the 3 are smaller than the 3 and the 4. So those are the 2 that I'm going to get to be the same. So the smallest number that 2 and 3 will both divide into is 6. Okay, so that's the number that I'm shooting for. But remember, they have to be opposite signs. So in order to get that y squared, the coefficient of y squared to be 6, I'm going to multiply everything times 3. And in order to get the y squared in this equation to be 6, I'm going to multiply by 2. But I need one of them to be negative. It doesn't matter which one. I'm just going to go with the second equation. Okay, so if I multiply everything in the top equation times 3, that gives me 9x squared plus 6y squared equals 105. Okay, and then in the second equation, if I multiply everything by negative 2, I get negative 8x squared minus 6y squared equals a negative 96. Okay, so when I add these 2 equations together, my y's cancel. 9x squared minus 8x squared is just x squared. And then when I add 105 and 96 together, I get 9. Okay, to solve for x, the x is squared, so I need to take the square root, and anytime I take the square root of a number, it's plus or minus. So x equals plus or minus 3. Okay, so I have 2 solutions for x, positive 3 and negative 3. I need to take each one of those into either one of the original equations and solve. I'm going to go with the top equation. Okay, so if I plug in, let's go with positive 3 first. So if I plug in positive 3 for x, and solve, I get 3 times 9 which is 27. Subtract 27. And that's 2y squared equals 8. Divide by 2. And y squared equals 4. Okay, again, we have our variable is squared, so we need to take the square root, plus or minus. So that gives me y equals plus or minus 2. So what that means is when I plugged in positive 3 for my x, I got out a positive 2 for y, and I got out a negative 2 for y. So far I have 2 answers, 3, 2, and 3, negative 2. Now I need to go back and plug in negative 3 for my x. But let's look at this. If I took negative 3 and I plugged it in right here, okay, all that's doing is that's changing this sign. Well, if I plugged in negative 3, when I squared it, it becomes a positive 9 just like the positive 3 did. So when I work it out, I'm going to get the same two answers. So that means when I plug in negative 3, I'm going to get out a positive 2 and a negative 2. So these are my four solutions: 3, 2, 3, negative 2, negative 3, 2, and negative 3, negative 2. These are actually two ellipses, and like I showed you at the beginning, two ellipses can have four solutions. So these are my four solutions. Okay, we have one more that we're going to solve by using addition. So remember, we need to get things lined up. Well, these are not both the same type of equation, so they're not going to line up perfectly, but we need to line up anything that we can. So I'm going to, in this first equation, I am going to rearrange it to get the x squared on the same side of the equation as the y. So if I subtract x squared from both sides, that gives me a negative x squared plus y equals 5. Okay, so that's just that top equation that's been rearranged. Now if I take the bottom equation and copy it underneath it, x squared plus y squared equals 25. Okay, so now I'm going to add these two equations together. Well, when I add these two equations together, my x squareds cancel. And I'm left with y. We can't add the y squared and the y because they're not like terms. So I have y squared plus y equals 30. All right, this is going to be a trinomial, so I need to be able to factor it. And so I'm going to, or it's a quadratic equation, so I'm going to need to be able to factor it. So I'm going to subtract 30 from both sides to get everything on one side. And that gives me y squared plus y minus 30 equals 0. Okay, so now it's a trinomial. Let me factor my trinomial, y and y. The factors of 30 that would subtract to give me y would be 6 and 5. That first sign goes with the biggest number. And so now that is factored. So I take each factor, set it equal to 0, and solve. Subtract 6, and I get y equals negative 6. Add 5. So y equals 5. Okay, so those are my y's. I need to have my x's. Doesn't matter which one I plug it into. I'm just going to go with the top equation. Okay, so if I take the y is equal to x squared plus 5 and I plug in negative 6 for y, that would be negative 6 is equal to x squared plus 5. Okay, so I'm going to subtract 5 from both sides. And that gives me a negative 11 equals x squared. Okay, so you know the next step to solve this would be to take the square root, but this is causing us to take the square root of a negative number, which means that this solution is imaginary. Okay, so because of this, that's not a solution. Well, let's try our other value. Okay, we know that negative 6 is not a good solution. So let's try y for 5. Or 5 for y. Let's plug in 5 for y equals x squared plus 5. Subtract 5 from both sides. And I get 0 equals x squared, and we can take the square root of 0. The square root of 0 is 0. So I have one solution to this system of nonlinear equations, and it would be 0, 5. So this is actually a parabola in a circle, and so they're only crossing at one point.